Welcome! In this series of videos, we will cover the design and implementation of a project, from initial design through coding and development to testing, using the PowerBasic compilers. Today we will start a new project to look at the use of blockchains within PowerBasic. So what is blockchain and what can we use it for? A blockchain is a digital record of transactions. This digital record is duplicated and distributed across the entire network of computers associated with that blockchain. It relies on a method of recording information that makes it almost impossible to change what has been recorded, without it becoming obvious that an attempt to amend it has actually happened. A blockchain is basically a decentralized database that is shared among computer network nodes. Transactional data from many sources may be collected, integrated, and shared using a blockchain cloud service. Individual data records are held as blocks within the blockchain, linked together using cryptographic hashes as unique identifiers. Data integrity is ensured using the blockchain, which uses a single source of truth to eliminate data duplication and increase security. Attempting to change data within a blockchain is prevented, as data can't be changed without approval. So if blockchain is the solution, what is the problem it can be used to solve? Let's assume we have 4 entities. It doesn't really matter what they are. They could be individual computers or even whole systems. Here we have North, South, East, and West. Each of these entities carries out transactions with the other 3. And each site keeps track of the transactions it has actually made. But there is, at the moment, no central authority with a list of all transactions. And each entity is unaware of transactions that did not affect them. So let's add a central entity, which we want to have a list of all transactions made in the order they occurred. Furthermore, we want some unique transaction number on each transaction, to allow them to be identified in the order that they occurred. This works fine for the central entity, as they have a record of every transaction, and any reporting can be done from its data. It does rely on the central entity always being there, and as such it's a single point of failure. So how could a blockchain approach help here? If all the entities had a copy of the transactions, then the database would be distributed across all of them, and no single failure could stop the system from working. Should one of the entities go offline for a while, and the others continued working, then it would miss out on one or more transactions. So before carrying out a transaction, an entity would need to check with the others to ensure that it had an up-to-date record of the transaction history before doing any new transaction, thereby allowing it to pick up any missing data. So what types of blockchain are there? Public. This public blockchain is a permissionless distributed database to which anybody can join and conduct transactions. Cryptocurrencies have an example of this. Private. The private blockchain. You need permission to join this network. This could be used within a company or organization. Hybrid. A combination of public and private. Some parts could be open to everyone and some parts could be restricted. Consortium. A consortium blockchain can be controlled by a group of identities as a private blockchain. So which is best? There is no simple answer to this question. It depends entirely on what you need to do within your own system, as each type of blockchain has its advantages and disadvantages. What we will do in the next video in this series is to look at creating a blockchain solution in Power Basic. But that's it for today. Thank you for watching.